Okay, today we need to learn the relationship between Cartesian and polar coordinates. Cartesian and polar coordinates. So in Cartesian, usually I have x and y. I mean, if this is our point, in Cartesian, I need to know x, what is the value of x, and I need to know what is the value of y. So I need to know the length of y and the length of x. So we can plot. So we can plot the point. We can plot the point. This is x and y. Now I need to know what is the relation between x and y with r and theta. This is r. This is s theta. This is s theta. So what is the relation between the Cartesian coordinates x and y and the polar r and theta? So if we consider this length is y, this one is theta. I mean, this one is y. This one is x. What is the relation between r, x, and y? If you have a triangle with right angle, 90 degree, then the hypotenuse r square have to be equal the summation of sides square, which means x square plus y square. This is the first relation. R square should be equal to x square plus y square. Also, if we look theta here, theta, we can say that x is equal to r cos theta. X is equal from the same triangle because we have right angle here. So x, the length of x can be equal to r cos theta because in triangle with right angle, cos theta is the adjacent over hypotenuse, which means cos theta is x over r. So x equal to r cos theta. Same for y. Y is equal to r sine theta. Because sine theta should be equal to opposite over hypotenuse. Opposite is y, hypotenuse is r. So y is r sine theta. If I need to find theta itself, it have to be equal to tan inverse y over x. Or tan theta is y over x. We can say that tan theta, this angle, is equal to opposite over adjacent, y over x. Tan theta is equal to y over x, or theta equal to tan inverse y over x. By using these four relations, r squared equal to x squared plus y squared, x equal to r cos theta, y equal to r sine theta, theta is equal to tan inverse y over x. Using these four relations, we can convert any point or any equation from Cartesian to polar or from polar to Cartesian, only using these four relations. So I need to use these four relations. To convert from Cartesian to polar. Okay, here I have Cartesian polar points. I have polar points. This is R. Now this one is R. This one is theta. So this is the polar form. In polar form, the first coordinate is R. The first coordinate in polar point is R. The second one is the angle theta. The second coordinate is the angle theta. The first one is R. The second one is theta. Now I need to convert this one to Cartesian coordinates. I need to find the Cartesian coordinate for the same point. So how to find x? Yes, x equal to r cos theta. Y equal to r sine theta, exactly. X equal to r cos theta. Y is equal to r sin theta. So here r is equal to 1 multiplied by cos 7 pi over 4. Here pi is 180. Here pi is 180. Okay. Same here. 1 sine 7 pi over r. So you can calculate this one. You can calculate this one. Square root of 2 over 2. Here minus square root 2 over 2. Should be like this. Second point. I need all of you convert the second point. We have r, we have theta. We need to find x and y. Same thing. You need to use the same relation. X r cos theta. Y r sin theta. But here r is minus 4, not 1. Multiplied by cos 2 pi over 3. This one minus 4 sine 2 pi over 3. Yes, this one equal to this one minus 2 square root of 3, or in decimal form also can. Okay. Third one, 2 minus 30 degree. 2 and minus 30 degree. Okay, calculate x and y. X, here, same, r cos theta. Y is r sin theta. So x is 2. Theta is minus 30 degree. Here, r is 2 sine minus 30 degree. X. This one equal to minus 1 or minus 1? Should be minus 1. Now I need, okay, the previous 3 we convert from polar to Cartesian. Now we will need to convert from Cartesian to polar. I will give you the point in x and y. Okay, then we need to convert from Cartesian to polar. We need to find r and theta. Now you have x and y. You need to find r and theta. How to find r? R square equal to x square plus y square, which means 11 square plus 5 square. 11 square plus 5 square, I think 146. I am not mistaken. 146. Then you need to find r, because this is r square. So you need to take square root for 146. Yes, this is r square. Okay, we need to find r, not r square, so you need to take square root. Square root of 146. Then we need to find theta now. Theta tan inverse y over x. Tan inverse y over x, which means that tan inverse y here is 5 over 11. Tan inverse y 5 over 11. 34.44. Okay. So the point is r is the square root 146. I don't know how. You can find the square root. Should be 12 something. And theta is 24.44. The most important thing when you write, start from R. The first coordinate is R. The second one is theta. When you write the point. Okay, 0 and 2. 0 and 2. Now the x is 0, y is 2. So r squared, same, will equal to x squared plus y squared. So 0 plus 4 is 4. R squared is 4. Which means that R is 2. R is 2. The square root of 4 is 2. Now theta, tan inverse y over x. Tan inverse y over x. Which means that tan inverse y is 2, x is 0. What is tan inverse for 2 over 0? Actually, 2 over 0 is infinity. 2 over 0 is infinity. So tan inverse for infinity is equal to 90 degree. Yes, exactly, 90 degree. 90 degree. Okay, keep this in your mind. Tan inverse infinity is 90 degree. Tan inverse minus infinity minus 90 degree. Okay? Keep this in your mind. Tan inverse infinity is 90 degree. Tan inverse minus infinity is minus 90 degree. So 2 over 0 is infinity. So the angle is 90 degree. Tan inverse infinity is 90. Tan inverse infinity is 90. So your point R is 2 and this one 90 degree. This one 90 degree. Actually, if you need to check your answer, okay. In Cartesian coordinates, the point is 0 and 2, right? The point is 0 and 2 in Cartesian coordinate. So if I need to plot x is 0, y is 2, this is my point. 0 and 2. This is in Cartesian. Okay, this is x and y. Okay, if r and theta in polar, sorry. In polar, I need to make 0. Here is 90. Here 180. Here 270. Okay, try to plot the point 2 and 90 degree. 2 and 90 degree. 90 degree is positive angle, so I have to go from 0. This is the 90 degree. If you take r equal to 2, you have this point here. This is the point 2 and 90 degree. So you are plotting the same point. This one is the same, this one in polar and Cartesian. This one in polar coordinate, you have the point 290 degree in Cartesian 0 and 2. But this is the same point. This one is the same point. This is how to check your answer. Also here, for the first example, if you plot 11 and 5 in Cartesian and plot square root for 146, 24.4 degree, 0.4 as angle in polar, you have to plot the same point. Then your answer is correct. Okay. Okay. Minus 4 and 4. Minus 4 and 4. The point. Minus 4 and 4. This is x, this is y. This is x. We need to find r first. We need to find r first. Okay, by finding r square is equal to x square plus y square. R square is x square plus y square. So 4 minus 4 square plus 4 square, which means that 16 plus 16 give you 32. 16 plus 16, which means 32. So r is the square root of 32. Don't forget to have r. Don't forget to have r. Okay. Not r squared. This is r squared. So you need to have the square root. 32. Square root of 32. You can find the value. Okay. This is r. We need to find theta. This is r. I need to find theta. So theta should be equal to tan inverse y over x, which means that tan inverse four over minus 4. Which means tan inverse minus 1.
Doctor,
Yes,
is y is negative 4.
y is negative 4. So let me check. Oh, okay. Okay, sorry. Minus 4 and minus 4. Okay, thank you so much. Okay. Minus 4. So here we have minus 4 square. Okay, and this one minus 4 over minus 4. So we have tan inverse 1. We have tan inverse 1. So we have tan inverse 1. Tan inverse 1 is 45 degree. Okay, yeah, I will agree with you until now. Tan inverse 1 is 45 degree. So should be the point is square root of 32 and 45 degree. Correct. Right. This is correct or not? Okay, check your answer. The point is minus 4 and 4. If I need to plot this point in Cartesian, right? Okay. This is x, this is y. If minus 4 is here, if minus 4, sorry, here, the point should be here in Cartesian. Right, this is the point, minus 4 and 4. Let's go for polar. Okay, for polar, we have 45 degree. Here we have 0, 90, 180, 270, 45 degree. Okay, this is the point. This is the angle 45. Here square root 32. So this 32 and 45. Is it the same point? What do you think? No. Yes, no. Here, the point in third quadrant. But this one, the point come in first quadrant. So these are not the same point. So this polar coordinate is wrong, not correct. You can take r negative. Okay. How to solve the issue? Actually, you can solve this issue by two methods, two ways. Okay, let's go back here first. I take r. Usually when we take r, the square root should be positive or negative. Should be positive or negative. Here I consider positive. Okay, but the point is not exactly the same point in Cartesian. So this means this coordinate is wrong. Okay, what is the correct? Either you can take, as your friend suggests, r negative with the same angle, then you will have the same point. Because if I take r negative, I will go on the opposite quadrant. So I will go this point. Okay, can. Or if you need to keep r positive, not negative, you need to add 180 to your angle. I mean, the other option is square root 332. Here, 180 plus 45. You need to add 180 to your angle. Because tan inverse 1 either equal to 45 or equal to 225. We have two angles, tan inverse 1. Okay. So you have to check after you get the polar point, plot the Cartesian one, plot the polar one, be sure that you're plotting the same point in the same quadrant. If not, I mean, like this case, I have in Cartesian the point in third quadrant. In polar, the point come in the first quadrant, which means that you need either to take r negative or you need to add 180 to your angle. Both options are correct. No need to write both. Choose one. No need to write both. Choose one. But now this one like this is incorrect. I mean, if you keep this one, that your answer is incorrect. So be careful because in polar, the Cartesian for the same point is not unique. But in Cartesian, the coordinate is unique. But in polar, we have for the same point 4 different polar coordinates. This is make problem sometimes. Now we need to convert equations, but we still use the same 4 relation. I mean, I will have Cartesian equations. I will convert to polar equations. And then we will have polar equation and try to convert to Cartesian. But we still use the same relation, x equal to r cos theta, y equal to r sine theta, r squared equal to x squared plus y squared, and the fourth one, tan theta. Tan theta, or theta equal to tan inverse y over x. Tan theta y over x, or theta equal to tan inverse y over x. Only these 4 relations you can use to convert from polar to Cartesian or from Cartesian to polar. We have these 4 relations. Okay. Now the first, this is Cartesian equations. We have 3 Cartesian equations. I will try to convert to polar. Okay, Cartesian equation should have y and x only. Polar equation should have r and theta only. X and y should be totally disappear. If I'm talking about polar equation, r and theta. If I'm talking about Cartesian one, should y and x. For Cartesian, y and x without any r or theta. You cannot on the same equation have y, x, r, and theta. Cannot. For Cartesian, y and x only. For polar, r and theta only. So y equal to x squared, this is Cartesian equation. Sometimes we call it rectangular equation because the Cartesian coordinate represent rectangle. Okay. Polar coordinate represent circle. So here I have rectangular equation or Cartesian equation. I need to convert to polar one. Y equal to x squared using the same relation. So what I need to do, I will replace y by r sine theta. And I will replace x squared by r squared cos squared theta. R squared cos squared theta. Now I convert from Cartesian to polar, but I need to, okay, in Cartesian, we try to make y as a function of x. In polar, try if possible to write r as a function of theta. So here we can cancel r with the square. So we have sine theta equal to r cos square theta, which means that r is equal to sine theta over cos square. Sine theta over cos square. Try to make r equal or r equal to function of theta. R can be the function of theta, if possible. If you can separate r from theta, is better. You can stop here, or you can simplify more. Sine over cos is tan theta. 1 over cos is sec theta. Or you can stop over sine over cos square, also acceptable. No need to make it equal tan theta sec theta. Also acceptable. So how to convert from Cartesian to polar? I replace y by r sine theta. Replace x square by r square cos square theta. Why? Because x is equal to r cos theta. X is equal to r cos theta. So x square will be r square cos square theta. Y from here, r sine theta, so y is r sine theta. Cancel the square with r. So sine theta r cos square theta, which means r equal to sine theta over cos square theta. You can stop at this point. You already separated r from theta. Okay. X squared plus y squared equal to 16. How to convert this one? Okay, you can use x equal to r cos theta, y equal to r sine theta, correct? I mean, if you make x squared, r square cos square, y square, r square sine square, and you add, correct? But here I will use this relation directly because easier. I know that x square plus y square is equal to r square, is equal to r square. So directly, we can say that r square equal to 16. R square equal 16. So this is your equation. R square equal to 16. If you use r cos theta, r sine theta, also correct. R square cos square plus r square sine square will be equal to 16. Then you need to use that cos square plus sine square equal to 1. Cos square plus sine square equal to 1. So you will have the same equation. R square equal to 16. R square equal to 16. Okay, xy equal to 1. Xy equal to 1. Here same. Replace x by r cos theta. Replace y by r sine theta. Equal to 1. Replace x by r cos theta. Replace y by r sine theta, which means equal to 1. So here r square cos theta sine theta equal to 1. Which means that r square will be 1 over cos theta sine theta. R square equal to 1 over cos theta sine theta. So now we have equation include only r and theta. No x and y have to be here because this is polar equation. This one Cartesian equation, xy equal to 1. This one polar equation. So polar equation, if you still have x and y, is incorrect. X and y should be totally disappear. Totally disappear. Okay, now we have, okay, these three, we have Cartesian equation, we convert to polar. Now we need to convert from polar to Cartesian. We need to convert from polar to Cartesian. Okay, we will start from the first one, r2 sine theta. R 2 sine theta. Now this one polar, I need to convert to Cartesian. I need to convert to Cartesian using the 4 relation, this one. R is same 4 relation, x equal to r cos theta, y equal to r sin theta, r square equal to x square plus y square, tan theta y over x. Now we have r2 sin theta. How we convert to Cartesian? When we convert to Cartesian, r and theta should be disappear. Okay, r2 sin theta. If I can have r sin theta, I can replace it by y, right? Sin theta alone cannot, but r sin theta can be replaced by y. So what I will do, I will, as your friend suggests, multiply the whole equation by r. Multiply by r. Then you will have r square equal to r sin theta. R square equal to r sin theta. So r square is x square plus y square, right? And r sin theta is 2y. R sin theta is 2y. So now I have Cartesian equation. Now I have Cartesian equation. X square plus y square is 2y. X square plus y square. You can stop here or okay, the second one, r equal to 3 over 4 cos theta plus 5 sin theta. R is equal to 3 over 4 cos theta plus 5 sin theta. Now this is a polar. This one is polar. And we need to convert to Cartesian. This one is polar. And we need to convert to Cartesian one. Your friend said we need to make R. Yes, exactly, equal to 3 cos theta plus 5 sin theta equal to 3. Actually, because this is R equal 1 over 1. So 3 times 1 should be equal to R multiplied by the denominator here. So R multiplied by 4 cos theta plus 5 sin theta should be equal to 3 times 1, which is 3. Which is 3. These two ratios are equal. So it means that 3 over 1, 3 times 1, r multiplied by 4 cos theta plus 5 sin theta will be equal to 3 times 1. 3 times 1, which means 3. Okay. Now we need to multiply 4 r cos theta plus 5 r sin theta equal to 3. Yes, exactly. Yes, very good. 5 r cos theta plus 5 r sin theta equal to 3, which means 4x plus 5y equal to 3. So now we have Cartesian. We have Cartesian equation. Okay. For C, 4 cos theta plus 4 sin theta. See, 4 cos theta plus 4, sorry, r equal. 4 cos theta plus 4 sin theta. Okay, we need to convert this one from polar to Cartesian. I will multiply both sides by r. I will multiply both sides by r. So we have r squared equal to 4r cos theta plus 4r sin theta plus 4r sin theta. Okay, r squared here, this equal to x squared plus y squared. R cos theta is for x, r sin theta is for y. X squared plus y squared equal to 4x plus 4y plus 4y. R is equal tan theta, so 6 theta. R is equal tan theta 6 theta. Tan theta is equal to sine theta over cos. And sec theta is 1 over cos theta. Then we can say that by multiplying like this, r cos square theta will be equal to sine theta. And then r is equal, let's multiply by r both sides. Right. Okay, he multiplied by r both sides, cos square theta. He multiplied this one by r, equal to r sin theta. Then x square equal to y. Okay, this one correct. But for me, no need to, okay, another option. I'll make it another second solution here. Actually, you already have tan theta equal to y over x, so no need to change tan. For me, you have r equal to tan theta multiplied by sec theta. So what you need to do is just r equal to tan theta sec 1 over cos theta. So r cos theta equal to tan theta. So r cos theta equal to tan theta. The x, r cos theta is x, tan theta is y over x. Tan theta is y over x. And then y equal to x squared. Okay, this is also can. But if you do also sine over cos, also correct. Two over 3 cos squared theta minus 1. Okay, now how we convert this one? R squared equal to 3 minus cos squared theta minus 1. R squared equal 2 over 3 cos squared theta minus 1. I will multiply like this. R squared 3 cos squared theta minus 1 equal 2. Then you have the 3 r squared cos squared theta minus r squared is equal to minus r squared is equal to. Then we have 3x squared minus x squared plus y square is equal to, because r square cos square theta is r cos theta is x, so r square cos square will be x square minus r square is x square plus y square. But be careful, minus here, you need to, when you write x square plus y square, you have to put the brackets. Why? Because minus here for both, for x square and y square. For x square, because those who are not putting brackets, you're just writing like that, they will consider the minus for x square only. They will consider the minus for x square only, which is incorrect. Okay, so this is why we have to write the brackets. We have to write the brackets. So x square plus y square equal 2. X square plus y square equal 2. Okay, now we need to 3x square minus x square is 2x square. Okay, make it more details. So this one 3x square minus x square minus y square equal 2. So you have 2x square minus y square equal to 3x square minus y square equal to. So this is Cartesian. The most important thing, be sure that no r and theta, you don't have any r and theta, only x and y, because this is equation in Cartesian.